Example number 4, graph. State the domain, range, and asymptote. Example A is g of x equals log base 2 of x. And I just cut something that I had brought over from our previous section. And so I said earlier that exponential functions and logarithmic functions are inverses. So 2 to the x is the inverse of log base 2 of x. And we learned earlier on that we reflect about the line y equals x, which means that we swap x and y coordinates between a function and its inverse. And so, I guess I'll call this g of x. So when I reflect about the line y equals x, aka swap x and y coordinates here, I get that my x is 1/4, 1/2, 1, 2, and 4, and that my y value, or my g of x in this case, is -2, -1, 0, 1, and 2. And now we can plot those points. So when we plugged in 1/4, we got out -2. So x is 1/4, we got out -2. When we plugged in 1/2, we got out -1. When we plugged in 1, we got out 0. When we plugged in 2, we got out 1. And when we plugged in 4, we got out 2, supposedly. And this is our picture. And I do have the picture that we graphed last time. So if we take this graph here and reflect him about the line y equals x, which is here, then he is going to give us the picture that I just drew on that other graphing grid. That looks like this. And swapping the x and y coordinates is what reflects us about the line y equals x. The other thing that we learned about inverses is that f inverse's domain is f's range and vice versa. So this is 2 to the x's range, which makes that log base 2 of x's domain from 0 to positive infinity. His domain, 2 to the x's domain, is log base 2 of x's range, so we can hit from -infinity to positive infinity on our y-axis. And what was a horizontal asymptote at y equals 0, which was here last time, is going to swap x and y coordinates, or what was a horizontal asymptote is now a vertical asymptote. And vertical asymptotes are restrictions on the domain. Now our vertical asymptote is at x equals 0. And this is the graph of log base 2 of x. And so this is kind of like a more basic graph. Could we take this graph, move them around, flip them upside down, stretch them, shrink them, whatever we need to do? The answer is yes. I I don't feel like I really saw this emphasized in the book very much, but domains are kind of a big deal in calculus. And so, domain of a logarithmic function is from 0 to positive infinity, not including 0. We don't actually hit 0. We have a vertical asymptote there, which is a restriction on our domain. And so we're just going to say note log base b of x has a restriction on the domain and maybe I should call it f of x equals log base b of x. On the domain, the restriction for logarithms, the inside of the log has to be strictly greater than 0. Inside of the log is strictly greater than 0. And so this can kind of apply some other ideas that we've used in the past. Again, your book, I don't recall seeing really it going into this very much, but domains are a big topic in calculus, so I do want to bring it up. Okay, so example B is f of x equals log base 4 of x minus 1. And again, we want to graph, state the domain and range, and asymptote. And so I'm going to outline this procedure in just a minute, but the first thing that we're going to do is look at our base logarithmic function. So base log function. And so in this case, that is going to be y equals log base 4 of x. And when we have y equals log base 4 of x, we kind of have two things that we're going to look at. This is true if and only if base raised to the answer equals the inside, or 4 to the y equals x. And this is how we're going to kind of incorporate our exponential function that we just looked at in the last one. So we're going to make an XY chart. Now, this XY chart goes for both of them, and a lot of times we will do a 3-point plot, not a 4-point plot. But based on this guy, or this guy, however you want to look at it, we're actually going to plug in our y values and get out the x's that go with them. And so, I think I made this one too long. We are going to plug in -1, 0, and 1 for y. And where are we going to plug that into? We are going to plug it into x equals 4 to the y. So I am saying that x equals 4 to the -1, or 1/4. X equals 4 to the 0, or 1. And x equals 4 to the 1st, or 4. And I'm going to sketch a mini picture. And my mini picture is going to be of my base function. So 1, 2, 3, 1, 2, 1, 2, 3. Oh, except for I think I need to go to 4. That's great. 2, 4, -2, -4, -2, 2, negative 4. Okay, so when we plugged in a quarter, we're pretending like we knew to plug in a quarter, we got out negative 1. When we plugged in 1, we got out 0. And when we plugged in 4, we got out 1. X comma y. So 1/4 comma negative 1, 1 comma 0, and 4 comma 1 are the points on my graph, which gives me a picture that looks like this. And our vertical asymptote is at x equals 0. And then we're going to ask ourselves, okay, what is happening to this little graph? Sorry, I got a little wobbly in there. Okay, and so this minus 1 is inside of the log. How do I know that he's inside? Because of these parentheses here. Inside is a side-to-side shift. We do opposite of the inside, so minus 1 inside means that we're going to go right 1. Kind of like we had with our exponential functions, our main things that we want to shift first are our asymptote and our 1 comma 0 point. So we need to go to the right 1. My asymptote is going to be at x equals 1. X equals 1. So again, vertical asymptotes are x equals asymptotes. Horizontal asymptotes are y equals asymptotes. On the test or quiz, I'm just going to ask you for the asymptote. If it's a logarithmic function, it's vertical. If it's a exponential function, it's horizontal. And you need to know which is which and state it correctly. Okay, we are not going on an elevator up or down right now. We are just shifting all of our points to the right 1. So my 1, 0 will now be at 2, 0. When y is negative 1, my x is a quarter away from the line here. And when I was 4, now I'm 5, comma 1. And this is my picture. And what is my domain here? What x values can I hit with this graph? I can hit from 1 to positive infinity. I do not get to hit 1. He is a vertical asymptote, a restriction on my domain, so he gets a parenthesis. Infinities always get a parenthesis. And what y values can I hit with this graph? Now, this one gets teeny tinier, closer and closer to 0. But this one, even though he's a slow grower, does keep actually growing forever, which is why our range is from negative infinity to positive infinity. And this is my solution this time. I am going to erase the weird green thing. I was just using it to explain. So this is my answer. Now I'm going to pause my video and then do the next one.